Welcome to today's class. In today's class, I want to solve examples, questions on machine. In the last two videos, I've taken my time to explain in detail everything that has to do with machine. In this particular video, we are going to be solving examples on this topic machine. So I will quickly go to the first question. Please, if you are joining this YouTube channel for the first time, please subscribe to this YouTube channel, like this video, share with your friends, and if you have any question, drop your question at the comment section. And the questions I will be solving will be popped up on the screen. So you'll be looking at your screen, you will see the question. The first question here says, the efficiency of a wheel and axe system is 80%, and the ratio of radius of wheel to radius of axe is 4:1. In order to lift a mass of 20 kg, calculate the effort required. So, you see the parameters in the question. One, we are told that the efficiency of a wheel and axe system is 80%. Look at it here. The efficiency is 80%. And the ratio of the radius of the wheel to radius of the axe is 4:1. So in order to lift a mass of 20 kg, so the load is 20 kg. We change this load from kilogram because load is measured in Newton. Multiply it by 10 so that we get load equals to 200 Newton. Then we are required to calculate the effort needed to lift the mass. So we are going to make use of the formula we already know, and that formula is efficiency of machine is equals to mechanical advantage divided by velocity ratio multiplied by 100. Here we are told to find E, and we know that mechanical advantage is defined as what? As effort. Our mechanical advantage is load over effort. So I'm going to write it as L divided by E. Then this L over E represents what? Mechanical advantage divided by the velocity ratio VR multiplied by 100. So this is the formula that I'm going to use so that I'll be able to find my E. Look at the one I'm looking for. I'm looking for E. Every other parameter is given. Now, what type of machine is this? This machine is one of the machines we discussed earlier in the last video. If you have not watched that video, please go ahead and watch the video because it will help you. So in that video, I said that if you want to find the velocity ratio of wheel and axe, if you are to find the velocity ratio of wheel and axe, what you do is you take the ratio of the radius of the wheel to the radius of the axe. So our velocity ratio VR is equals to capital R over small r, which is the same thing as ratio, and that is given in the question as 4/1, which is equal to 4. So my velocity ratio is 4. So let's substitute the parameters now. We have gotten all the parameters into this formula for efficiency. That efficiency is 80. Instead of writing E there, we put 80 is equal to load is 200 divided by E is unknown, then divided again by velocity ratio is 4 multiplied by 100, this 100 outside. So this is going to give me, we will now deal with this expression, this will be 80 is equal to 200 over E multiplied by, when we change division sign to multiplication, it becomes 1 over 4, all multiplied by 100. So we now have 80 is equal to, open the bracket, you now have 200 times 100 over, then what you have down is E times 4. If you make E the subject, this E multiplied by 4 here, which is a denominator, multiply this 80, and when that is done, we will now say that E is equal to 200 times 100 divided by 80 times 4. So we'll do our division now. This 0 here, we'll cancel this 0 here. Then let's say this 4 here cancel itself. This 4 cancel 20, that will give you 5. What else? We have 2, or let's say 4 go into 8. 4 go into 8 is 2. 4 go into 100. That will give you 25. So what we have left, 25. Then we are left with 5 times 25 give you 125 over 2. So our effort is equals to, you divide 125 by 2. 2 divide 12 will give you 6. Then 2 divide 5 will give you 2. Remainder what? Remainder 1 over 2. And 1 over 2 is equal to 0.5. 0.5. So this is the effort required to lift the load. So we are done with this. We will now go over to the next question. So the question is popped up on your screen, so you can be going through it on your screen. Question number 2 says, a plane inclined at an angle of 30 degrees to the horizontal has an efficiency of 60%. Find the force parallel to the plane required to push a load of 120 Newton uniform up the plane. So from the question, the parameters in the question is that we have the angle of inclination of the plane is 30. We are told that the efficiency is 60%. Then we are told to find the parallel force required to push a load of 120. The load is what? 120. We are asked to find effort again. So the same, similar to the last question. So the only difference is that this machine now is an inclined plane. Unlike the other machine, the last question we treated, the question was on wheel and axe. So here, the first thing we are going to do is to write our formula, and our formula is what? Efficiency is equals to mechanical advantage divided by velocity ratio multiplied by 100. Here, do we know the velocity ratio? Yes, we can find it. Look at it. Theta. Our velocity ratio is the same as VR is equals to 1 over sine 30. And 1 over sine 30 VR will be equals to 1 divided, sine 30 means 1 over 2. So our result is 2. So we are going to substitute. But then we're asked to find effort, and effort is inside this. So we can rewrite this expression as efficiency is equals to E. Efficiency is equals to load over effort, which stands for mechanical advantage, divided by velocity ratio multiplied by 100. So let's begin to substitute. We have our efficiency to be 60% is equals to, what is the load? The load is 120 divided by E, unknown, the effort, divided by velocity ratio is what? 2. Multiplied by 100. So here we can deal with this expression. This is going to be 60 is equal to 120 over E times 1 over 2 bracket 100. So I change this division to multiplication, then these two will be inverted, becomes 1 over 2. Then let's proceed. This is going to be 60. Do the same thing I did in the first question, equals to 120 multiplied by 100 over E times 2 by opening the what? The bracket. In that case, I want to make E the subject. This is cross multiplication. Cross multiplication will help us. This times this, this times this. In that case, we are going to have our E to be equal to 120 times 100 divided by 60 times 2. In that case, 60, okay, this 0 cancel this 0. 6 cancel itself, 6 going to 12 is 2. Then 2 cancel itself, cancel this 2. So we are left with E is equal to 100. So 100 Newton. So 100 Newton is the required effort. So we'll go over to the next question. Please, if you have any question, please drop your question at the comment section. And if you are just joining, please do well to like this video and subscribe to this channel. Question number 3 now. Question number 3 is displayed on the screen. So join me as I read. A machine with a velocity ratio of 30 moves a load of 300 Newton when an effort of 200 Newton is applied. Calculate the efficiency of the machine. So in the question, we are told that the velocity ratio of the machine is 30, and we are given that the load moves a load of 300 Newton. The load is what? 300 Newton. And the effort applied was 200 Newton. Then the question is just to find the efficiency. So we'll quickly go to the formula for efficiency. Efficiency is mechanical advantage divided by velocity ratio multiplied by 100. Then, do we have mechanical advantage in the question? No, it was not given direct, but they gave us parameters that can help us to find it, which is L over E. We can simply say that mechanical advantage is equals to load over effort, and it is equals to, what is the load here? 300 Newton divided by 200 Newton. So we are left with mechanical advantage of the machine is 3 over 2. So we are going to substitute. We already have mechanical advantage now and velocity ratio. So we substitute into the formula. We are asked to find efficiency. Efficiency EF is equals to mechanical advantage is already gotten as 3 over 2. Then that is mechanical advantage 3 over 2 divided by velocity ratio divided by velocity ratio, which is equal to 30 over 1 multiplied by 100. So we now write that our efficiency is equals to 3 over 2. You change this division to multiplication, becomes 1 over 30 multiplied by 100 over 1. In that case, we are going to have that efficiency is equals to 3 times 100 over 2 times 30. That is multiply the numerators and the denominators. So we are going to have this 0 here, cancel this. these 3 here, cancel these 3. We are left with efficiency of the machine is 10 divided by 2, which is equals to 5. So our efficiency is 5%. The efficiency of the machine is 5%. That's how to solve the problem. We'll go over to the next question, question number 4. The question 4 is popped up on the screen, so join me as I read the question. The question says, a lift is used to carry boxes to the top floor of a hotel, 20 meters high. A total weight of 100 kg of boxes was carried up in 20 seconds. If the useful output of the engine driving the lift mechanism is 1.2 kilowatts, calculate the efficiency of the engine of the lift mechanism. So in the question, you can see the parameters in the question to include 1, you are told that the height of the hotel is what? 20 meters. Then the load, a total weight of 100 kg. That is the load. The load is 100 kg, but to change the 100 kg to Newton, you multiply kg by 10 to change it to Newton. That will give you 1000 Newton. Then the time for carrying this load by the engine or by the lift is 20 seconds. Then the power of the engine driving the lift, is 1.2 kilowatts, according to the question, which will change to watts. Power is, the standard unit of power is watts. So since we have kilowatt, we multiply it by 1000, so that goes to watts. So we now have power is equals to 1200 watts. Then we're asked to find the efficiency. How do we tackle this question? Pay good attention. We are going to use the first formula in the first video I made concerning efficiency. That formula says that the efficiency of machine EF is equals to work output divided by work input multiplied by 100. This is the first formula I wrote in that video where I discussed machine. So in that video I wrote that efficiency is the same as work output divided by work input multiplied by 100. And we've talked about what work output and work input is in that video. So if you have not watched the video, you can go back, I refer you back to that video so that you have a better understanding. So now, let's look at the work output in the question. The work output is the work that is done by the machine, and the work done by the machine is the same as the load multiplied by the load distance. So I can rewrite the expression for work output to be equals to load multiplied by load distance. So the work output is the same thing as the load multiplied by the load distance. Then what is the work input? Work done by the machine. And we are told that the machine, the engine that is driving the lift, that the power of that engine is 1.2 kilowatts. And when you are to deal with power in relation to work, you discover that work is equals to power times what? Time. So the work that is done on the machine is the power of the engine multiplied by the time during which it performed the task. So it is going to be power multiplied by time, then this 100 here. So this expression I'm going to use to find the efficiency. So I can now proceed efficiency is equals to load. What's the load? 1000 Newton multiplied by load distance. Load distance is 20 meters. Divided by what's the power? The power of the engine is 1200 watts multiplied by what's the time? Time is 20 seconds. So efficiency is equals to, so I can deal with this. If I look at this, 0 cancel 0, 2 cancel 2, then this cancel this. Okay, there is multiplied by 100 is omitted. This 100 here. 0 cancel 0, this 0 cancel 0. Then I'm left with 10 over 12. So that's going to give me 10 times 100 over 12. I can still see that this is the same as 1000 over 12. So if you press your calculator, you are going to get that efficiency is equals to 83.33%. That is the efficiency of the machine. So I'm going to drop 2 more questions. So I would want you to make attempt on the question. Please drop your comment at the comment section. If this is the first time you're watching my video on YouTube, please do well to subscribe, like, and share. Thank you.